in this first lesson, we are not going to jump straight into formulas. We're going to talk about where the idea of arithmetic sequences actually comes from, who discovered them, how they were used in the past, and why they're still one of the most important ideas in maths today. I think it's a nice way to see that maths didn't just appear in a textbook, it started as a way to make sense. The idea of arithmetic sequences goes back thousands of years. The Babylonians were already using simple number patterns for trade, astronomy, or land measurements. They noticed that when you kept adding the same number again and again, the results formed a regular pattern. They recorded these patterns on clay tablets, which were basically the first multiplication tables. They didn't call them sequences, but that's exactly what they were working with. Later, the Greeks studied this pattern in more systematic ways. Mathematicians like Pythagoras and Euclid were interested in how numbers and shapes were connected. For example, if you draw a row of dots and then add another row with one more dot and then another with one more and one last one with one more dot, you'll get a triangle made of dots. The total number of dots follows an arithmetic pattern. This is how they started linking number patterns with geometry, something that would later become the foundation of algebra. One of the most famous stories about arithmetic sequences is about a boy named Gauss, who later became one of the greatest mathematicians in history. We even call him the Prince of Maths. He discovered so many things, not just in numbered theory, but also in geometry, astronomy, and physics. When Gauss was about 10 years old, his teacher asked the class to add all the numbers from 1 to 100, and most of the students started adding them one by one. But Gauss noticed a pattern. So he saw that if you pair the first and last numbers, so 1 plus 100, and then 2 plus 99, or 3 plus 98, and so on, every pair makes 101. So there are 50 such pairs. So the total is 50 times 101, so 5050. That quick observation is exactly how we find the sum of an arithmetic sequence today. Gauss didn't just calculate faster, he understood the structure behind the numbers. As mathematics developed, the idea of arithmetic progressions appeared in many cultures. In India, for example, mathematicians like Aryabhatha used them to study astronomy in planetary form. And in the Islamic Golden Age, scholars such as Al-Khwarizmi, for example, a true genius, wrote one of the first books on algebra, and the word algebra actually comes from the title of his book, which is this, which I don't know how to pronounce, but when these texts were translated into Latin in medieval Europe, arithmetic sequences became a part of the formal mathematic education, and they've been there ever since. So, why does this topic still matters today? Because arithmetic sequences describe constant change, situations where something increased or decreased by the same amount every step. So you can see them in finance, in engineering, in coding, and even in nature whenever growth is steady. They're also the foundation of many other mathematical ideas, linear functions, algebraic reasoning, and even calculus. They're all built on this same principle. So, arithmetic sequences are one of the oldest mathematical discoveries, from clay tablets and ancient geometry to modern science. What started as a simple pattern, adding the same number repeatedly, became one of the main tools for understanding how things change in a predictable way. In the next lesson, we'll use what we've learned here to actually build the formulas step by step. Thank you for watching.